Illinois, Urbana-Champaign, master's and PhD at the University of Washington. He teaches classes related to climate change, and water cycle. He's an active member of the American Geophysical Union, American Meteorological Society, and the regular organizer of international research workshops and sessions. He's involved, we were talking a little bit earlier, he likes doing this, he gets involved in the community, faith groups. One of the things that I thought was really interesting in his bio, take a second, that he doesn't know about. When I was in school, I'm quite sure that none of my professors included my name, any of my work in their bios. In his bio, he talks about two students presently working on untangling rival theories of how climate change affects surface water availability differently from how it affects precipitation. One of his master's students, the disproportionate effect of climate change related flooding minority communities in North Carolina, and 4 recent graduates. Really cool stuff that I don't understand at all. Quantified long-term trends in extreme summer viewpoints across the U.S. and what controls jet stream's response to climate change, and whether the evolution of the jet to date gives us any insight on their. So
I'm not going to get into that. It's much more climate change.
I
fascinating.
thought it was really cool. He was highlighting his students' work in his bio. So
Oh yeah, no, my bio was just that little piece next. No, none of that stuff. That's not my bio. I was just talking about the little bit.
Well,
but no, I appreciate it.
on your page, you talk about your
Oh yeah.
on your page, some of your students and stuff.
Yeah. Wait till I was actually presenting. You know, we're ready. All right. So welcome. Thanks so much for coming. Thanks for the amazing introduction, John. Everybody hear me okay? Right. And I think if this looks a little bit grainier, watch out. Feel free to flip off some of the lights so you can see what's on the slide a little bit better. There could be some contrast issues. I didn't notice that. I said that earlier. Yeah, it can be a little bit. A little bit of current. Yeah, whatever y'all think. Y'all did that. Sorry, I should have said that earlier. I got a parent that nothing that I needed for this. Oh, that's great. That's fantastic. Okay. So, right, you all are here because you care a lot about Earth, presumably, and it's our only home. So, the start with first, and then I do this. I'm not going to do a lot of work on slides or anything, or a lot of detailed bullet points. I don't know how to present to the audience. Very well, or the kids were coming too. Wait for the kids.
Not wait, but I'll be here.
Get my file in. Okay. So, I just do this series of questions and answers. Well, basically, I'll ask them frequently asked questions about climate change, and I'll hold you guys. You guys show a hand, both on who has heard the claim and who thinks it's true. And then we'll discuss. And we'll sort of give the perspective from a working climate scientist, which is me. So I'm different from the perspective you get kind of out there in popular discussion. Okay, so I assume we got something in the chat on Zoom here, and we need to answer that.
From Katie.
Right, yeah, she says it's hard to hear.
Oh, hard to hear. Okay.
Extra.
Okay, should I just keep going for now?
Keep going.
Okay. So here's our planet, here's our precious beloved planet Earth. Right, so who has heard that this planet is warming up? Great. So who believes it is true that the planet is warming up? All right, awesome. I'll get 100%. This is true, but I do want to show the evidence. I actually want to show you some things about this that I think will be useful here. So, oh god, this is going to be a mess. So I'll have to make sure not to accidentally but here's this really nice series of maps produced by NASA that shows this really well, which I want to show you some real NASA data on planet warming up, and may not be the type that you've seen before. So this is NASA's division here in New York City that actually does the temperature analysis. They collect all these, satellite surface data, figure out how things warming up. I just want to show some maps, some kind of geography professor technically, right, of how the planet has warmed up over the years. So here is it. So what this is a map of, right? Little.
Yeah.
Oh, nothing. Okay, well, I've seen it on my screen. I'm seeing it on my screen, but I don't see. I don't see anything. I think the presentation is still on the PowerPoint slide, even though. Yeah, guess maybe I should have said that if you're, I didn't realize I was gonna be on Zoom, so I didn't think about this again. If I'm on Zoom, I think what you wanna do is share not the PowerPoint application, but the whole, you know, do the option where let's you share your whole desktop, not specifically PowerPoint. Here, I can do it from here, but I can stop sharing. Here, I think I know what I need to do.
Yeah.
So I'm gonna stop sharing and then I'm gonna share the entire screen. There we go. And that will fix it. There we go. So, that's a little better now.
Yeah.
There we go. Right. Yeah. Sorry about that. No, I wasn't thinking about the fact that I was kind of checked out with remote stuff a long time ago. I'm really preferring in person. So, okay, now, like I said, you can get very able to anyway, this is the map that NAP put together, and they do this for every month, right? This is the map of the difference between how March 2024 was and what quote normal was, which I think they're defining here as an average of all the margins from 1951 to 1980. So probably a lot of y'all remember most or some of those margins from 1951 to 1980. Heard about them. And this is the map of the right, the difference in temperature between March 2024 and March just included, and an average of all those margins from 1951 to 1980 when we were sort of getting our idea of what normal is. And you see that almost everywhere on the planet, this past March was much warmer than the prior, right, than the sort of what we had an idea of the March normal, right? So it's not just the planet old warming, but almost everywhere on the planet tends to be warmer than it used to be. And these are by fairly large numbers. So this, unfortunately, we always do the Celsius and science because you kind of mentally convert to Fahrenheit. So anywhere in orange here, right, between 1 and 2 Celsius warmer than sort of what that idea was normal. So that's between about 2 and 4 Fahrenheit normal. So anywhere in orange here was warmer than what we thought of as normal by about 2 to 4 Fahrenheit. Anywhere right here was warmer than what we thought of normal by about 4 to 8 Fahrenheit, right? And anything in this dark, you know, red was warmer than normal by more than 8 Fahrenheit. Again, by normal, we mean that whole idea of normal from 1951 to 1980. So what it's showing is that since that time, right, since that generation, the planet warmed up quite a lot. And a lot of the quirks on this map is why there's, you know, Europe is really warm and there's periods really cold, just specifically because, you know, that month. But you can also make versions of this that are more general, or they don't just focus on March 2024, but focus on the whole year. Let me just do this really quickly. Try this again. I can't think we're going to do annual, and let's go instead of just the year 2024. Let's take a 30-year period that would. Oh God, I don't need to stop. I need to see up on this, but 2023, and let's go to the equivalent 30-year period. 30 years earlier, 1919. So the last 30 years, about 40 years. Okay, there's 30 years. Okay. The last 30 years for the 30 years in the 1950s, 60s, and 70s. So the pop culture being different, the music being different, and the, all kinds of stuff being different. The technology being different. Also, here we're going to see how the temperature was different between those periods. Oh, it doesn't like it. Why?
You're beginning.
Say we're fewer years. 1994 to 2003.
23.
23. Well, I'm getting all cylinders today. All right. Here we go. I just want to do that. I don't like to have it far enough advance that I can do it in real time for you guys. You can do the really data, right? I'm not going to pull a map out of my pocket. But here's what I was trying to do, right? So now we can see how is this most recent generation warmer than that older generation. You can see that clearly almost everywhere in the world is warmer. That's really what I'm trying to make, is there's not just one graph. Right, it's that almost everywhere in the world, right, is warmer in the current generation than it was the prior generation, right? So now you can see that that's a little bit more modest period per hour, taking a longer period, but so anywhere in this orange here, between about 1 and 2 Fahrenheit warmer, right? And then the period anywhere this dark orange here is more like between 2 and 4 Fahrenheit warmer. So it's not warm, right? It's not massive amounts, right? It's a few Fahrenheit, but it's enough to be measured. So why does that matter? Right, we're going to talk about that. Okay, so let's go to the next claim. So now we can make that kind of forming up everywhere. Okay, so who's heard that each warm year is warmer than the last? All right, quite a few of you. Who is true that each year is warmer than the last? Quite a few. Okay, so it turns out that is not true at all. It is not true that each year is warmer than the last. So we can see this. We'll go to this kind of classic graph that you may have seen. More than that kind of map. We don't like that graph. I want a different graph that makes it really clear. The famous graph, global, and it makes your temperature This is just the global average temperature, right? It's the global average temperature difference from 1951 to 80. So essentially, the average, you make a map like that every year, then the average across that map. You can see, so this is time going across the 3880, which is when they had enough data to do this, up to 2020. So over the last 140 years of history, you've got the global temperature, the global average temperature every year. So you can see it's not actually true that every year is more than the last, right? This particular year, 2016, was warm, and 2017 was a little cooler than 2016, and 2018 was cooler yet than 2017, but then 2019 warmed again, right? It's up and down, right? Year to year, it's up and down. It's not true that each year is warmer than the last, right? But in the long term, right? The current generation, like we saw, right, that last, several decades are clearly warmer than, when more the middle of the century, which were warmer even than our great grandparents' time. So that's what we're well, it's not that every year is warming the last, right? But in general, the weather now is warmer, right, than what the prior generation, but the generational time scale. Who's heard that each decade is warmer than the last? Right, who, and you can kind of do this based on the graph, but who believes it's true that each decade is warmer than the last? Right, usually not always, right? So 1940s warmer than the 1950s, right? Even though we were spewing greenhouse gases in there that whole time, right? But that wasn't something, right? We didn't stop many greenhouse gases in the 1950s, right? So it's before economic boom. Europe wasn't doing the air like crazy. Yeah, the 1950s were cooler than the 1940s. So it's not even true necessarily in our, modern era of global warming here that each decade is warmer than the last. Usually it has been, but not always. So I wouldn't be surprised if at some point in the future we find a decade randomly cooler than the last, right? Because the reason for this is that Earth is naturally variable, right? Climate varies anyway, right? Even if we weren't changing climate would be varying, nothing in nature is ever constant. So you've got all kinds of natural ups and downs that are superimposed on the long-term rise. And so what we all think this was some kind of natural up in the 40s and natural down in the 50s. You see a little bit of the hint of that happening here too. We had this sudden jump in warming right around 2015 or 2016. So we would be surprised if we, later see a little, plateau or something. So point is to a bumpy road up, and that bumpy road up is because of nature, right? It's because nature has all these natural cycles that are being superimposed on the long term. So usually each decade has been warmer than the last, but not necessarily the rule, right? That might always happen. Okay, great. So, and I want to even show this more dramatically. So I've got another website. This is actually from NOAA here, and I'll show you that this is these claims about how it's not true that each year is warmer than when after each decade is warmer than even more when you look globally. Because all the graphs for the global average, right? Nobody lives the global average, right? Nobody experiences the global average temperature. So let's actually look at like North Carolina or Charlotte or something. So I think North Carolina will demonstrate as well. So we could stay here. State time periods of amazing no resource where you can like plot out all kinds of climate graphs, all kinds of places. So your state, and let's go again yearly, not 1 month, 12 months, and I know that because I just quirky, here we go, all months, and well, I don't want that one December, 12 months ending in December, that's the schedule. And let's go, we have one if they have, then we don't do it in Alabama, we do North Carolina, so let's get that. First in the alphabet, so we get the correct. All right, so here we go. The average temperature every year in North Carolina is 1895, according to NOAA. So that's, I know the trend line on here. Let's check this out. So plot it. Let's for NOAA to do its math, and here we go. So here is the temperature of North Carolina every year since 1895. Right, a lot of things have happened in North Carolina since 1895, but notice that in North Carolina, it's certainly not true that every year is warmer than the last, right? No way that's true. And it's certainly not true that every decade is warmer than the last, right? So look, I mean, the 1920s and 30s and 40s were really warm in North Carolina, and that got cold, right? In the 50s and 60s and 70s, then dramatically warmed up again into the present, right? So in terms of temperature that you, right, living in a particular place experience, it is not true that every decade is warmer than the last. It's a bumpy road up. Right, climate change in North Carolina is the fact that in general, when we have a warm year in North Carolina these days, right, say, 2019 or 2020 were quite warm, those are warmer than the warm years that our great grandparents experienced back in the teens and 20s, right? And similarly, when we have a cool year in North Carolina, say our year 2014 in North Carolina is pretty cool by modern standards, that cool year is still a lot warmer than the cold years that our great grandparents experienced back in the 1900s and teens. So this is what climate change looks like globally, right? It's that we still have lots of natural swings between warm and cold. It's called weather, right? But it still keeps happening. So some years are really warm, some years really cold, some decades warm, some decades cold. But when we have a warm year decade, it's warmer than the warm year decade that our grandparents were experiencing. Right? When we have a cold year decade, it's warmer, but it's not as cold as those years. And I think that actually answers what I was going to ask you next. Who has heard that temperature swings are getting more extreme? Right? I've already answered the answer is no. Right? Temperature is not swinging around more wildly today than it was their great grandparents. That's another huge misconception about climate change out there in the media. Right? You hear all the time in the press, oh, the temperature swings are getting more extreme. It's swinging around between warm and cold more intensely. No evidence for that at all. Right? If anything, it seems like temperatures these days swing around a little bit less than the temperatures in our great grandparents' time. And instead, well, the effect of climate change is just to warm everything up, right? The warms are warmer than the warms in our great grandparents' time. The colds today are not as warm, or the colds today are not as cold as the colds in our great grandparents' time. So I've talked about this with my students, is like the rising tide of temperatures, right? Climate change is the rising tide that lifts all temperatures, right? It lifts low temperatures, it lifts the high temperatures, it lifts them all. So every time I go outside, which you want to think, let's see, Tacoma, so I think North Carolina average is warmed about a little over 1 Fahrenheit, right? So like the per decade, it's good for century here, sorry. And this was that works so quickly. Here we go. So about 1 degree Fahrenheit per century, so a little bit more than 1 Fahrenheit since 1895. So basically every time you're outside in Earth, you just want to think is, if we had more of the planet, that it would be about 1 Fahrenheit less outside than it is now. And every time you're outside, that kind of is rising by the little temperatures, right? It's not creating more extreme swings, it's not like, right, just lifting everything. Okay, great. So that was, I gave that one away. Very good answer before I had to ask. Okay, so let's go to another question. So who has heard, creating this temperature swing business, which is clearly not true. Who has heard in general that climate change is just making the weather get more extreme weather than climate change, worse weather disasters.
Heard it.
We've heard those kinds of claims. Who believes that is true, right? That climate change is making the weather work more. So I would say that's about maybe half, right? So because the terms we're going to show that there are some kinds of weather extremes, the climate change making more extreme, of course, and there's some kinds that it is not making more extreme. Of course, we're going to go through that here. So I think we're done. I think we're done with the web now. So let's just go back to the slides for the remainder of this journey here. And let's, okay, so let's start about hot extremes and cold extremes. Oh, sorry, this is what we were doing, right? We know that we're not swinging back and forth more wildly between hot and cold extremes. Sorry, I'm just warming up. Sorry, I've gone away from my slides here a little bit. This is what I could have when I posed the question of are hot and cold swings getting more extreme? And no, right? It all drives it. Right? Global warming is making this day warmer and it's making this day warmer. Right? It's making the hot form of the cold warmer. So it's getting warmer. Okay, so here's what I want. Okay. So here are some pictures of different weather situations, right? I'm going to sort of pull you guys about each of these, right? So I'm going to take a little tour of climate change effects and weather. So who has heard that rain is getting more extreme?
Oh, yeah.
Okay. Who's heard that rain is getting more extreme? Who believes it is true that rain is getting more extreme? We have a few. Okay. So this is one actually where that sort of popular idea really is true. Rain is getting more extreme. This is very much unlike temperature, right? Temperature swings are not getting more extreme, right? Just everything's warming up, warming up, warming up. The rainfall really is getting milder and more extreme. So when it rains, it's raining harder, and then we're waiting longer for the next rain event. So it's raining less often than it did on our great-grandparents' time. Then when it rains, it's pouring. So rain is getting more extreme. One of the scary things about climate change to me is the climate science. So we're swinging more between extremes of wet and dry. This is series pictures I love here. This is a really important reservoir in California that supplies a lot of the water you grow all over vegetable across the United States, Oldham Lake. So I want to grow vegetables to grow in California, Central Valley. This reservoir is really important. And it was, full to the brim in 2011, and then 3 years later, there was a really bad drought in California, and it dropped to a really low level, and then it dramatically filled back up again after this picture take. So we're seeing more of these swings between extreme dry and extreme wet than we were in the past, right? So rainfall really is getting more extreme. And that the reason briefly, right, is that because as it gets warmer, that rising tide of temperatures, it can hold more water vapor in it, which means it takes longer and longer and longer to recharge the air to hold enough water vapor to form a storm. Then once that storm comes, it dumps more rain, right? Then that same storm would have come without rising temperature. without that increased water vapor amount in it. So precip, right, rain really is getting more extreme. That's one where that popular idea about weather getting more extreme is true, right? Not true for temperature, right? It's true for the heat waves, it's not cold, right? Temperature is everything going up. The rain really is more wild swings more on the time. Okay. Who has heard that wildfires are getting more extreme? Who would say that it's true that wildfires are getting more extreme? Yes, so again, absolutely. This is again one of the really scary ones. Wildfires really are getting worse. They're getting way worse, especially in the United States, but around the world. Right, something like 10 times the area burns in wildfire every year now than even a generation ago, than even 30 years ago. That's crazy. Right, the amount of area burned by wildfire in the United States each year is roughly 10 times the average that it was in the 80s. And for a whole bunch of reasons, the climate change is drying up. Climate change is causing forests to overgrow. And forests are actually overgrowing for a lot of reasons. Right, we've had a lot of fire suppression in the Western United States, where we've been putting out fires that should be naturally burning. We've allowed forests to grow much bigger than they actually would, but also there's some climate change factors too. So in particular, there's more CO2 in the air, that's plant food, right? Plants grow more, right? The more CO2 helping plants grow great normally, but it does provide for really catastrophic wildfires when they happen, right? With bigger fuel, right? For those wildfires. And also that fuel drying out, right? The air is warmer and dry out everything on the surface. The average, we're having more wood in these forests, drier wood. That is the recipe for wildfires. And we have a whole bunch of other issues too, which I won't get into. Water is really getting way worse over time in the United States and also worldwide as well. Okay. What about hurricanes? Let's see. So who has heard, I'm gonna break this into two. Who has heard that climate change is causing there to be more hurricanes?
Yeah, we heard that, yeah.
Who thinks it is true that climate change is causing there to be more hurricanes? Yeah, a few. So actually this is another myth. There is no change over time in the number of hurricanes that we know about, right? That is hard to right? We can look back 120 years, we don't see any kind of long-term trend in hurricane number in the Atlantic or any other part of the world. There's some early studies that did, and I think that's what kind of set it off in the popular record. 50 years ago, they reported that there's more hurricanes over time. That turned out to be due to a statistical error that involved that they weren't thinking about the fact that before modern weather satellites, there were a lot of hurricanes that we missed. Right, we didn't know about them because they were out of the ocean, they didn't affect land. So if you account for those, you get no trend in hurricane numbers over time. Or if you just do that kind of number of hurricanes that have hit land over time, because those we can detect, right? We know when a hurricane hits land, absolutely no long-term trend over time. So no sense that we're getting more hurricanes over time. There's some unique reasons for that, so get off on why that is. Okay, who's heard that hurricanes are getting stronger over time? That they are getting stronger than hurricanes past. Who believes that is also true? Yeah, so that is absolutely true. That's what's backed up the evidence, right? So my colleague Thomas always says it's not more storms, it's stronger storms. Right? It's not more storms, it's stronger storms. Not more storms, stronger storms. Right? The number of hurricanes that came, but they are stronger on average than the hurricanes that are great-grandparents or grandparents experience. And that again comes down to heavier rain. Ironically, remember we talked about how like every time it rains these days, it's raining harder than it did in the past, right? That increased water vapor in the air, right? Because it's getting more extreme. And it turns out that the formation of rain with water vapor releases a ton of energy into the air. And that energy is powerful for hurricanes. Right? And so hurricanes are becoming more powerful because they're raining harder, right? And then that heavier rain releases more energy into the air that powers the storm. Sometimes you hear that hurricanes are getting stronger because the ocean waters are warming up. That's big on a misunderstanding of how hurricanes work. I'm on too. The way I read it is hurricanes are not getting more powerful because of the warming of the ocean water. Hurricanes are getting more powerful because it's raining harder and the formation of the rain releases the energy power of the hurricane. Okay, we'll talk about that later. Okay. Sorry. Okay, let's keep going. So who has heard that climate change is making there be more tornadoes, or stronger tornadoes, more tornado damage? Who believes that it may be true that climate change is making critical tornadoes from students? I'm seeing a few. So this is again one where there's just no evidence for this. We don't see any kind of long-term trend in U.S. tornadoes, U.S. strong tornadoes, things sort of great number of tornadoes, anything like that. We don't know anything about how climate change affects tornadoes. We're really quite ignorant. And part of the reason is there's no obvious trend in the data. And also, we fundamentally don't understand what causes tornadoes in the first place. You know what some of the ingredients are? We still don't know what that navigation is that causes one to result in under tornado and the other one not a tornado. We really don't know what it is. So until we can understand that, it's going to be hard to understand how climate change would affect tornadoes. So there have been some changes in tornado patterns over the decades, particular Great Plains states, the Great Plains states, the Kansas, Oklahoma, Texas, Nebraska, and so forth. There are a lot fewer tornadoes than the frequency of tornadoes are dramatically declined. And actually, the frequency of tornadoes kind of in south and see how them in the city has gone up. We have no idea why. No clue. We have no idea what that is, climate change or something else, or we're just trying to figure that out. So we just don't know anything about climate change effect on tornadoes. So if you're watching the news and you're talking about tornadoes, and say, oh, global warming, right? That's nothing bad to this there. Oh, like hurricane, we know global warming makes hurricanes stronger, we understand exactly why. Right? Tornadoes, we have no clue. A little bit.
I've heard recently there was an article about how hurricanes can intensify much more quickly,
Absolutely.
and they blamed it on warmer Gulf water temperatures.
Yeah, so I would say it's not so much about those warmer temperatures, it's about the fact that the hurricanes, because the air is warmer, are raining harder, and so then they're releasing more energy, right? So hurricanes that have dumping heavier rain, and the formation of that rain releases energy in the atmosphere, and that energy is really what's powering the hurricane. So again, the warmer temperature thing, that's true in a season, right? Like if the ocean surface is warmer, all else equal, you have a stronger hurricane. The problem is that it doesn't really say anything about climate change, because what climate change is doing, forming everything, like rising temperatures, so forming the ocean surface, but it's also forming the upper atmosphere, which is the other side of the hurricane is a machine that moves energy from the warm ocean surface to the upper atmosphere. And both of those things are warming. And it's that temperature difference that's really important for the hurricane. Not the ocean temperature per se, temperature difference between the ocean and the upper air, and that's not changing climate change. So really, when I'm talking about climate change, I really think it has to do with the heavier rain. So maybe my take on it, or the answer thing. Anyway, but if you want to know, I don't want to make sure that we get to a few things before we all to leave, and with I have a question. Okay, so one more type of weather. Who has heard that climate change is getting like speaking like snowstorms or winter weather, or things about cold or extreme, right? Like maybe more snowfall or heavier snowfall, frequent snowfall.
Yeah.
Nobody heard that. Temperatures were, winters are warmer than our grandparents' winters. It's just harder for people cold enough to know here in North Carolina. But interestingly, when you go up like Article, I'm originally from Chicago, so Chicago, all getting heavier. And over time, right? Because it's still cold enough to know there in winter, right? Sure, global warming has warmed winters in Chicago, and I'm not take them over three things very often. The Chicago winters is still plenty cold enough to snow, and so it's snowing harder when it snows in Chicago, for the same reason that it rains harder when it rains, right? Yeah, there's perspective, snow and rain are the same thing, right? Just snow melt on the way down. Right? When it rains you, right? That's the snow is somewhere up there, that's no melt before it reaches the surface. So yeah, you don't care whether it's rain or snow, right? The exact same reasoning that led us to every time it rains harder. As long as you're in a place where it's cold enough, winter, like in the Northeast, I don't know where this is, Brooklyn or something. When it snows there these days, it snows harder, right, than it did during the time of the great grandparents or whoever was living in the town. So climate change interestingly can actually make winter weather worse, right? As long as it's still cold enough. And certainly in places like North Carolina, we're barely cold enough to snow anyway, right? The fact that it's just not cold enough to snow is the dominant factor, right? Why we're seeing way less all North Carolina than our grandparents. Okay, great. Okay, cool. So that's getting all specifics. Let's go back to the generality. Now we've kind of gotten to sort of a lot of the difficult things to do. I'm going to start getting into awful things and start putting it into context. Okay, so who has heard that the global warming we're having today is unprecedented? Right? It's nothing like this has ever happened before.
Oh, yeah, I've heard it.
Okay. I think it's a really interesting thing. I'm going to sort of break it into two parts. So first, I'm going to say that the warmth we're experiencing right now, the temperature, the global temperature we're experiencing now, is not unprecedented anyway. The Earth has been way, way warmer than this before. So this is an artistry construction based on fossil, right? Based on fossil evidence of what the Arctic, the high Arctic, looked like about 20 or 30 million years ago, which wasn't even that warm compared to some past periods. But if you go back 20 or 30 million years in the geologic record, this is what the high Arctic looked like, right? It was a mild swamp with lots of huge craters and leaves and evergreen trees and stuff. This is nothing like what the high Arctic looks like today. It's like the wasteland with snow and a little bit of tundra. Right? So the planet has been massively warmer than today when you go back into the geologic record. So the temperature is Earth doesn't even care, right? This is a mild temperature for Earth. The temperature is not unprecedented in any way in Earth's history. history, right? And actually, this is relatively mild time. You actually go back to times in the geological record where the high Arctic was so warm, right? That's a much warmer planet today. Right, the top goes into the temperature of like a hot bed, right, at that time. So clearly the warmth is unprecedented. But what is unprecedented, right? What really is unprecedented about the current warmth, crazy to me, is this speed of it, right? It's not the warmth, it's how fast we're warming up. We don't know of any time in Earth's entire geological history, going back 4 billion years, that it is warmed up as rapidly as it's warming up now. And that's just because, again, humans are fast and nature is slow, right? This warming, we've gained about degrees Celsius from the planet over 100 years. Nature, it usually takes thousands or millions of years for the climate to change by degrees Celsius, not hundreds. So this warming is way faster, right, than anything that nature has seen. And in fact, that's a problem for a lot of species, right? Species are adapted to slow climate change, but they may not be adapted to the quick climate change in the perspective that we're experiencing right now. Okay. All right, so that's that. All right, let's keep going. Let's get more big claims about climate change here. Who has heard that climate change is because of us, people, right, and what we are doing?
Oh, yeah.
All right, everybody's heard that, right, of course. Who believes that is true, that it is largely because of what we're doing? Again, I'm kind of giving that away. I've been talking about it as if it is, so it probably is. But I want to break this down a little bit more. I want to get into exactly what we're doing that's causing it. So who's heard that climate changes, or a lot of climate change is being caused by like plastic waste, like where you can make too much plastic and we're plastic bags and plastic straws. Who has heard that plastic bags and plastic straws are causing climate change? Only a few. Who believes it is true that plastic bags and plastic straws are causing? No, but you guys are good. You guys are distinguishing climate change from the environment, which is good, right? Plastic waste is a huge problem for the environment, right? The oceans, the rivers, and everything. But it's not the main reason the planet forming up. So again, so that even climate change ever issue in your head from environmental, right? They're related. Okay. Who has heard that cows are a big cause of climate change? Particular gases that the cows give off. Okay. So, well, cows are around. No, there's some cause, but this idea that the methane, coming out of cows is a big cause of climate change, not much to that, right? Cows are only 10% of the methane that human society is making, only about 10%. And methane is not the main reason the planet is warming up anyway. It's the minor secondary reason the planet is warming up. So you got 10% of a minor secondary reason. So methane coming out of cows, not a main reason the planet is warming up. It's a reason that it's a tiny reason. Cows are actually important for global warming, not mostly because of methane coming out of that, for other reasons. Okay. Who has heard who is here the burning of fossil fuels for things like transportation and industry was causing climate change? All right, this one's more popular. Who believes that is
Sure.
so? Yes, democracy wins, right? This is overwhelmingly the reason that the planet is warming up right now, right? It is the everyday, day-to-day use of fossil fuel to power our society, right? It's not like one evil polluter or something, right? It's not like, oh, this one company where they were not making fossil fuels. No. Is that we use fossil fuels for everything in our society right now, and that in a lot of ways economically a great thing. That's what a lot of people live with a lot of poverty and have a lot of civilization, not be living in huts like my great grandparents did in Europe, right? We're doing great, but the problem is that a side effect of the fact that we use all these fossil fuels is that, I'm sure I coordinate the slide correctly, right? Is that they when you burn them, right, that these fossil fuels are made of carbon. When you burn them, that carbon oxidizes into CO2, right? Carbon dioxide, and it goes in the air. And it turns out that CO2 is really good at sort of serving as a blanket for the Earth. It's like kind of any gas with 3 or more atoms can stop sort of the radiant heat from the Earth from making it out into space. Right? The sun is heating the Earth, right? The Earth is cooling by radiant heat in space, but normally in balance, right? But things like CO2 in the air stop some of that radiant heat from getting out. They intercept it before you get out, and so that's like just putting on a blanket or get the heat get warmer. So we were sort of thickening the planet blanket, the kind of natural blanket of these gases like CO2 is an incidental consequence of this amazing invention of fossil fuels that got us out of poverty, right? But unfortunately, right, the fact is that all the CO2 has been building up in the air, and that's sort of like putting on paper and paper and paper. Right? So that's why that's what's causing the rising high temperatures. That's why in every weather situation today, it's a few Fahrenheit or Fahrenheit warmer than it was in our grandparents' time. That blanket protecting us from the coldness of outer space is a little bit thicker, have more CO2 in it. I think that's sort of the quick introduction to that. I just want to distinguish, that not all the fossil fuels are created equal in this regard. So here's natural gas, right? Natural gas, ironically, is also mostly emitted methane, but here we're not talking about methane emitted in the atmosphere. We're talking about methane as a fuel to burn, like say your gas stove or natural gas fired power plant. So when natural gas is burned, to make energy and power our lives, right, there's a lot of hydrogen in the air, but it doesn't really do anything, right? It's carbon, it does. So, burning natural gas makes the same amount of energy, doesn't put that much CO2 in the air compared to something, right? Put CO2 in the air, but at a moderate amount. However, burning oil, right, things like gasoline and diesel and so forth, right, that's got a lot more carbon, right? A lot more of that energy is coming from the burning carbon. So burning, getting the same amount of energy from gasoline or diesel, but it's got a lot more CO2 in the air compared to getting it from natural gas. Finally, getting it from coal, that's just pouring tons and tons of CO2 in the air. Because we burn this all the combustion products as CO2. Coal's mostly made of carbon. Got only got a few hydrogens in it. So that's why we always hear coal is worse for the climate than natural gas, right? That's why, right? Because coal's got a lot more carbon in it than natural gas. So not all fossil fuels are created equal when it comes to the effect, right? We're particularly concerned about coal burning, right? Coal burning is disproportionately responsible for all the CO2 flooding it. For natural gas burning, they're responsible for some of it, but coal bigger. Okay, great. Okay, so that's fossil fuels. All right, who's heard that deforestation, cutting down trees, is also part of what's warming the planet? Who believes that is? Yes, that is also true, right? Because these trees' bodies are made of carbon, right? So when they got cut down, eventually that tree decays, right, or turns into something. Eventually that carbon reaches the atmosphere, oxidizes into CO2, so they can put like it more. So this is an important secondary reason for global warming. The primary reason is still the burning of fossil fuels. I believe that's responsible for about 90% of our current carbon emissions as the planet, species, are coming from burning fossil fuels. The other 10% are coming from cutting down trees. So we can't ignore either. Cutting down trees, again, would really bad environmental, right? It's horrible in the places where it's happening, right? But it's not the main reason for warming. The main reason for warming is fossil fuels. Okay. Who has heard that fracking is causing climate change? Fracking is making climate change. Well, here's a picture of a frack pad where they're getting natural gas. Who believes that is true? You here. So I'd say fracking is kind of a double-edged sword for climate change. Fracking has really helped us get off coal, right? Because coal ruled the US energy supply for a long time. It was cheap as fuel. Fracking made natural gas cheap. We replaced a lot of coal power generation around the world in the United States with natural gas power generation because fracking. That caused carbon emissions to decline, right? We were emitting much less carbon in the early United States than we were 20 years ago. That's when we were fracking, right? Causing coal would be less economical and natural gas would be economical. That's great. The fracking, I think, is also kind of hurt progress on climate change when it comes to oil and natural gas. The things that we use oil and natural gas for, fracking has made it easier to use oil and natural gas for those things, right? So maybe if we hadn't invented fracking, right, maybe the transition to, say, electric cars might have happened after this sort of need for them after. The fracking is sort of a double-edged sword in terms of fuel climate. Really helped a lot in terms of getting off coal, but then it kind of it's been part of the reason why we still use a lot of oil and natural gas because it's cheap, right? Because the fracking. Notwithstanding that COVID, all the crazy COVID related fluctuations last year, broadly oil and natural gas is still cheap enough that it's economical achievement. Okay, cool. So let's see, what else do I want to talk about here? Okay, who's heard that some of global warming we experience, obviously a lot of it fossil fuels, but who's heard that some of it is also natural, right? Some of it is also part of the natural cycle. Or maybe all of it's permanent, depending on the media levels you agree. So who believes that's true that some of climate change today is probably natural. Here's where I'm again, so I got a lot of good for that. I'm gonna go against the conventionalism a little bit here. I would argue almost certainly not. And here's why. Right, here is what the global temperatures look like over time, kind of when you go zoom out to more natural scale. Some of the textbooks that I use, climate change, every year. So now this is 10,000 years of history, right? On the x-axis, we've got from 10,000 years before president all the way to the present. We've got the global temperature, difference on the vertical here. So let's just walk you through what happened here. So we were kind of coming out of the ice age about 10 or 12,000 years ago. The ice age was actually quite cold. The ice age was really cold. That was obviously natural, right? The Earth orbit was different. We were able to grow ice in Canada, right? So it was really cold. Look at that orbit was changing. We were coming out of the last ice age. And then once we were really out of the last ice age, around 10,000 years ago, people in the Middle East invented farming. And so we have the Earth warm enough to actually farm, right? It's a really important time in human history. The Earth stayed quite warm all the way up to kind of the early Egyptians and Mesopotamian society. The Earth quite warm. And then it kind of started to slowly cool over thousands of years. By the time we got to ancient Rome, you know, and Greece and China and stuff, right? You know, the temperature was, you know, a few tenths of the Celsius colder than what the Egyptians did, but not big, a few tenths of the Celsius. Kind of slowly cooling. And that kind of started to get a lot cooler. And by the early modern period, kind of the 1600s, 1700s, and 1800s, we were really in what scientists now refer to as a little ice age, where it's quite a bit colder, right, than it had been for a lot of human history. And not way colder, right, but enough to be measured by modern sort of archaeological and geological records. So, wow, okay, and then all of a sudden, out of nowhere, for this long-term cooling trend, and all of a sudden, out of nowhere, boom, right, we warm up this crazy amount in the present day, and this amount is way faster than anything Earth history has known. So, to me, what this looks like, if we were in a natural cycle of cooling, and then we interrupted that natural cycle when we discovered combined coal and started burning it for energy, right? And the reason we were in a natural cycle of cooling, and I should have said this, the reason why Egypt was warm and Rome was a little cooler, and then the colonial era, it was even cooler than Rome, is because the Earth's orbit is changing, right? The Earth's orbit naturally changes, that's what causes our ice ages in our warm periods, but really the Earth's orbit to change, take about a last ice age, the Earth's orbit is in configuration to make northern latitudes warm, we were very warm, and then it kind of started changing in a way that would have taken us back to another great ice age. So we would have eventually been heading into another great ice age in say another 10,000 or 20,000 years. But we rudely interrupted that trajectory by discovering coal and stuff, and so now the temperatures is shooting up. Because machines are efficient, right? Machines are faster than nature, right? We've done 100 years what nature would have taken several to. So naturally, we would have been cooling, I think. So I don't think any of her warming is natural. It's a natural trajectory would have been cooling warm in this view. Okay. Right. So let's get into some big questions. Everybody have a little more time or go ahead and stop. More time. Let's get back to zero questions here. All right. Who has heard that? Oh, sorry. I had some words. I don't usually have words in here. I gave it the words. There were the words for this. Okay. There it is. All right. Playing the risks and the discovery hole in the 1800s. All right. So, okay. Here we go. This is more fun. This is more fun. So, who's heard that global warming is going to be like apocalypse, the end of the world, like Mad Max? You know, oh my God, the end of human civilization, the end of human species, we are doomed, right? The future is going to be horrific like this. Who's heard that?
Oh, yeah.
Who thinks that is true, that we're really dooming ourselves as a species and civilization climate? I would really put it back, right? There's going to be lots of places on Earth where it's plenty nice enough to live, right? Even if we warm the planet several degrees Celsius. Remember, we've only warmed 1 degree Celsius that much. But even if we warm our 5 Celsius, it's only a warming of 7 or 9 Fahrenheit. That could be a problem in a lot of places, but certainly in Canada it's be fine, right? Or in the Pacific Northwest, right? No problem. There's only a few places where people can live just fine. The species is not doing very much headed for like an apocalyptic world, right? But don't think that matters, right? Who's where the climate change is likely to be dystopian, right? For a world that has some negative aspects. We don't necessarily want to live in the center. You guys know the famous dystopian movie from about 10 or 15 years ago called 100 Days. If you haven't seen it, don't worry about it. It's kind of for dystopian world that came up with. Where kids have to kill each other or something, which is kind of horrible. But who has heard that we might kind of have a dystopian future with climate change? And who might agree with that or disagree with that? A few. You guys are more tentative now. So yeah, this is how I would maybe not kids killing kids and entertainment, which is what they're moving about. But there's a lot of things about the world that we would move into due to climate change. It would be kind of dystopian, right? It would not be a world we want to live in. So maybe the most obvious, right, is the sea level. Right, one consequence we all know the world's warming up, right? A lot of the heavy polar ice bodies are melting, right? Greenland's melting, Antarctica's melting. So if we really warm up the planet a lot, right, we're gonna raise the sea level by a few feet, and then we're gonna have all these people have to move, right? So the Miami metropolitan area, right? It's like Charlotte, it's not affected by the right? But like, where's everybody who used to live in Miami gonna go? If Miami's gonna run salt water, right? That's like 5 million people, right? What about the entire country of Bangladesh, right? And both that country with hundreds of millions of people is really, really low lying. So if the sea rises 5 or 6 feet, which you have over the next several generations, sort of like I'm in a retirement home, right? That that's hundreds of millions of people that have to move. And then it actually gets worse because there are actually huge swaths of northern India and northern China, populated by 1 billion people, where it's research indicates that sort of in another couple of generations, if we don't do anything about hydrogen, if we don't get fossil fuels, that it's going to become too hot to human in those places. People live, right? It's actually going to be too hot to human outside. People surviving in several regions of Asia, and maybe even potentially in parts of the United States and parts of the Middle East. And so, again, that's gonna be like a billion people that have to move or die. Right, so not list, but dystopian, right, I don't necessarily want to be in that future. So don't think about it as Mad Max, right, think about it as more like 1984 or something, right, where the world hasn't ended, but it's not a world we wanna live in. Okay, so that's sort of my take on that, here, and this is more you talk about, but I think that's what we can visit. Okay, who has heard that climate change is irreversible, right? We can't go back, right? It's like breaking an egg, you can't put the egg back together. Who would say the climate change is irreversible? Who would say it's true that climate change is irreversible? You guys are optimistic, that's great. So I would say, in terms of nature, it really is irreversible. We're putting all the CO2 in the air, and nature has no way of taking that CO2 out of the air other than the rocks, right? Eventually the CO2 reacts with chemicals that are weathered from rocks and goes back into the rocks. But that takes like hundreds of thousands of years. So nature cannot reverse climate, right? We are going to be every pound of CO2 we put in the air for fossil fuels is stuck up there for essentially 100,000 years. However, we could potentially invent machines to reverse climate change, right? Or people working on machines that would take CO2 out of the air, put it back in the ground. So that's the only way we're going to reverse it. Right, if we can actually invent additional machines that would take CO2 out of the air, put back on the ground, we don't have those yet. There are people working on that. So that's my take on that. Okay, sorry if I'm boring you all. All right, so you want me to keep going? You want me to stop? Right, keep going. Okay, I'm gonna make sure I'm done. Then we started late, all the technical issues here. Okay, so who has heard that we only have X number of years, we only have 7 years, we only have 8 years, we only have 10 years, and then it's game over with climate. It's over. Who would believe that is true? Fewer hands, you guys are starting to read me well. So I don't think that's true at all, that's such a silly idea. That comes from the specific targets that are put in by the international community. So like in the world of climate diplomacy, which I think is kind of divorced from the world of climate reality, it's not talking about things that matter. But in the world of international climate diplomacy, the really fact that the target of having the world not warm up more than 1.5 Celsius warmer than before the Industrial Revolution. Well, we've already warmed up 1.1 Celsius from before the Industrial Revolution. So almost certainly we're going to pass 1.5, right? We're going to get off the fossil fuel that fast, right? We're trying to, but it's going to take a while. So almost certainly we're going to blow through the 1.5 target. But these statements usually come from that target. They say, oh, well, we would have to completely get off of fossil fuels in the next 8 years if we wanted to avoid blowing past that 1.5 target. See, I don't think these targets, it's not that these targets are magic. They're just sort of guideposts put in place by the diplomatic community. But really, it's just like every further degree Celsius just makes the air that much warmer, and makes the fire that much worse, and gain that much worse, and the sea rise more. So sure, like it would be nice to live in warming 1.5 Celsius, but it'd be a heck of a lot better at 1.5 Celsius than 2.5 Celsius and 3.5 or 4.5. Right? So it's not like there's some magic point, it's just a tipping point and then game over. But it's just that the faster we can start getting on alternative fossil fuels, or at least using fossil fuels responsibly, the better, because the fewer Celsius we end up with. So I don't like this idea of like, oh, the limited time that's game over, it's just like need to get in quickly, because again, CO2 doesn't go away, right? We burn fossil fuels, CO2 just stays in the air, right? There's no magic pipe to take it out. So the sooner that we stop doing that, right, then the fewer Celsius we end up warming up, right? And the less the problem there is. Okay, cool. Let's keep going here. So finally, let's get a little optimistic, right? So let's talk about what we can actually do. Let's talk about prospects for solving the problem. I think that's why a lot of you are here. Again, you sort of get my take on it, or supporting climate scientists right now as an activist about that, what's actually seems to be happening in the economy right now that's sort of aggravating that or solving this. Okay, so I really like to break this down. I like to break this down into 4 sectors, right? Because really, talk about the problem of fossil fuels, right? The problem is burning fossil fuels. There are 4 broad things that we use fossil fuels for as a species. We use them to make electricity, we use them to power vehicles, we use them to heat buildings, and we use them for direct manufacturing. And the answer kind of depends on what we're talking about. So electricity, that's actually pretty optimistic because solar has gotten really cheap. So we have the giant solar farms now. This is the most popular form of new electricity production today. Right? We're not building a whole lot of new coal plants and natural gas plants, building a lot of these, right? And they're huge and they're really cheap, they're getting better and better and better every year. They're kind of taking over the electricity business. They're starting to, right? Especially in the US and a lot of developed countries, but also recently in the developing world too. We have huge amounts of these being built today in China, India, and so forth as well. You know, like solar, we're not talking about rooftops. Rooftops look nice, but it's just a drop in the bucket compared to this stuff. This is when climate scientists say solar. this is what they're talking about, not rooftop solar. Right, big industrial scale solar farms, they're actually displacing, gas and coal off the grid, right? This is starting to happen. And then also, and this happened, we found skip that as the graph. Pointed that even Greenpeace underestimated how quickly solar electricity was adopted. Solar is increasing really, really fast right now worldwide. Also, wind is really cheap, right? It's gotten a lot cheaper than it used to be, and wind is also growing really, really fast. So solar maybe growing even faster. But because solar and wind are growing so fast, right, and also because battery storage of the intermittent power from solar is growing really fast, right? That means that I'm pretty optimistic that eventually we're going to mostly get off of fossil fuels for electricity, maybe in another generation, right? So I think that's that helps. One thing that's slowing that down is that you need to build a lot more power lines, right? Bring all that wind power from North Dakota, or bring all solar power from Arizona or something, where people live. And part of why solar and wind haven't been coming on even faster than they already are, at least in the United States, is a lot of people don't want to move high tension power lines in the backyard. So there's a lot of slowdown on the process because of the power lines. Power lines are the weakest link. But if we get more power line built, then we can very quickly transition electricity off of fossil fuels and solar. And that's already happening. I think it's kind of unstoppable. But it'll go faster after that happens. So we're really optimistic that we'll get off of fossil fuels to electricity use. Electricity use electricity generation is the biggest single piece of this. Okay. Vehicles, we'll see, right? There are the electric cars, heavy, doggy, whatever problems with them, they're expensive, they're kind of hitting some bumps in the road, but I think overall, I wouldn't be surprised if in another sort of 20 years, more people are using electric cars, right? Very electric cars. Yeah, so that may take a while, right? It seems like that's moving in that direction too. I will drive a gasoline car because I don't think electric cars are very economical for me. I just paid a huge amount for one and it wouldn't be as good a product as a gasoline car I drive. Not like out there preaching and saying you use an electric car now, but it seems like this is broadly moving in the direction where I wouldn't be surprised if, in another 50 years, they're quite common and normal, maybe they work well. So that'll help too, right? These are electric cars, right? We won't be burning gasoline, they'll be using electricity from the grid. The grid will have a lot more wind and solar at that point, right? It won't be that much coal and natural gas anymore. And so that'll be pretty clean. All right. Home heating, that's gonna be a little bit harder, right? So in South, we have these heat pumps, and I think most people use these heat pumps down here, happy with them, but the problem is in Chicago, where I'm from, nobody wants to install this. Because winters are cold, right? And everybody's thinking natural gas heat is really the only thing that can keep you comfortable in like a Chicago or in the winter. So there's a lot of natural gas heat up there, and I'm not sure how easy it's going to be because people use electric heat instead of natural gas heat in those climates. So I don't think my parents ever would. They're very clear about climate change. I don't think they would ever offer natural gas heat, electric heat. So that's going to take longer. And I don't really know where that ends up, but there's certainly efforts to sort of replace natural gas heat with electric heat. I think that's going to be harder. And then finally, for direct heavy industry, this is another maybe about a quarter or so of the fossil fuel we use is direct fossil fuels in industry, chemistry, or for intense heat. I think this would be like things like the use of natural gas to make fertilizer, use of coal to make steel, the use of oil to make plastics, things like that. We actually need that chemical. That's going to be hard. We can't just substitute with the solar panel. Right? You can't make steel using solar panel. So you can't make plastics using wind turbines. You have to actually use oil. So this is going to be harder, right? You're going to have to invent whole new chemical processes to do that. And there are just some progress. There's a lot of buzz right now about using hydrogen instead of fossil fuels. You have to make the hydrogen using clean electricity. We don't just have a lot of hydrogen gas available. You can make it with electricity, and then if that's clean electricity, then you have a clean way of doing all that's kind of where all the buzz and hydrogen is in industry right now for how the industry would decarbonize. It would be where we're replacing all the fossil fuels with hydrogen made from clean electricity. But again, that's sort of kind of it's on paper right now. It's kind of a little demonstration phase. But I think that's probably how they would do this. But again, I don't expect that to really happen at scale anytime soon. Or to be wrong. A lot of buzz about it, right? Might be happening faster than anything. Okay, so that's all. I've never gotten the end of this. So comment and please stay around for Q&A. Great. I want to hear you get you applaud to somebody else. Somebody got much taller back. All right, so you in the suit exactly. I think you're waiting on.
I'm curious about a couple of things that you mentioned, and thank you so much for being here for your insight on and research on the topic.
Sure.
The first thing that grabbed me was the issue with cattle. Cattle, beef.
Oh, sure, right.
The industrialization of the beef industry.
Right.
It's not the methane that the cows
Right.
produce, but the loss of natural space required to feed all of those cows.
Oh, yeah.
That is such a huge problem from a climate standpoint. Is that not
Right, well, I would say, I mean, that's part of it, I think the big, so if it really is true, right, that beef is much worse for the climate than other meats. They're not doing that thing, right, I don't think it's primarily what you're saying either, right? The reason that beef is so much worse, right, for climate change than pork or chicken or turkey or any other meat. Is because it needs so much fuel, right, so much fossil fuel to produce 1 pound of beef, right, the cows are big, right, the plants that water them, process them, tons and tons and tons of fuel. All that feed you have to grow for the cattle, right, most cattle today is corn fed for economical reasons, so you turn into grass fed in the pork for you, right, so growing all that corn, and trucking it, right, to the feed plants, and then taking it to like where the cows are actually eating the corn, these horrible capos and stuff, right, that takes a ton of energy. So beef is worse for the climate than pork and chicken and turkey, not for the methane, just because you have to use way more fossil fuel, to make a pound of beef than a pound of pork or a pound of chicken or turkey, that's why. And then in terms of local impacts, yeah, these capos are really bad for the environment locally, right? You don't wanna live next to one of these, right? But I don't think that's making a change in the climate, and I'm trying to separate climate change and the human environment. Right, the cattle feeding operations are awful for the environment locally. The reason it's so bad for climate change isn't specifically those feeding operations, the whole business. The fact that you have to use so much fossil fuel to produce beef industrially, which is how we produce it now, because it's cheaper than natural ones. Right, so economic always rules, so you open the cheapest option.
The other comment that I was
Yeah.
going to just add real quick is the replacing all the cars that are gas with electric or hybrid is not a long-term solution either. Public transportation is where that problem gets remedied. Just because I sell my gas-powered car and buy an electric car, somebody else has bought my gas car to use it to cause traffic on the interstate.
Well, yeah, that actually, I mean, it's.
That's a much more productive way of eliminating.
Oh, sorry, I didn't talk there, yeah, so really public transportation helps, so places that are dense enough to have public transportation, like there are the urban parts of Charlotte, absolutely, right? We should be building the Silver Line and all these things, would be great. Right, that would help in a lot of sort of more suburban and rural parts of the United States where it just wouldn't be practical to have public transportation, so we have to have vehicles, right? We have to have vehicles for work, we have to have vehicles to get things around, we're not gonna be able to replace the whole truck fleet of the world with like freight trains. We're gonna have to have a lot of vehicles, vehicle engines, and so as we start to go to more electric, sure, like you originally thought you got cars from the old, eventually you get, right? So I wouldn't be surprised if in 20 or 30 years, the whole vehicle decided to turn over, right? So a car these days, right, so using a different analogy, right? We mostly have gasoline cars these days, but the overall fleet these days is more fuel efficient than the fleet that their parent grandparents used, because the newer cars are more fuel efficient. And sort of like maybe my dad's old, his old unfuel efficient, his old, bunker car from the old. Then that person eventually sold something else on business and junkyard no longer operating, all the new stuff is efficient. So I really think that eventually electric cars is very good help. But then of course public transportation helps on to urbanism in general, right? I mean, people are living closer to each other, it's more practical to have public transportation, it's more practical to have walking and things like that. Just walk to the grocery store, you can drive there. So the questions are urban more than come into this too. But we know a lot of people don't have those. Oh, wow, somebody, I don't know who to start with, I think, and right next to the previous speaker, I think you've been very.
Quick question, you
Yeah.
said, it's really hard to get CO2 out of the atmosphere.
Yeah.
But in an offhand comment, you mentioned about the density of vegetation, the vegetation is consuming a lot of
Oh.
CO2. So is the overall impact of that just not material to the side of the problem?
Oh, yeah, that's a fantastic question, yeah, that actually sort of points to how I can present this better. What I really should have said when I'm talking about the fossil fuels and what they're doing and building up. So what we have to think about it is that, like, so we're burning these fossil fuels, and they're not just building up in the atmosphere, they're burning up in all parts of the earth that they're building up. So if they're building up in the atmosphere, it's CO2, that's causing climate change, right? So that's getting to like it. They're also building up in the ecosystem, as plant matter, sort of great in a lot of ways, they're greening the plants, but it's also causing more wildfires when they happen and stuff like that, and some other consequences. And also building up the ocean water, so causing a drop in the pH of the ocean water, it's called ocean acidification, it's killing a lot of marine life. So it's this triple effect, right? Building up in the air, building up in the vegetation, and it's building up in the ocean water, causing distinct and interesting effects in all of them. And
Taking it out of the air.
no, you don't want to think about it that way. You want to think of it as it's just building up, and building up. It's not a puzzle between them. We're flooding the environment with CO2, and it's building up everywhere the carbon exists in the environment. So the air is full of carbon in the form of CO2, that means the air is putting on more carbon. The ecosystem is full of carbon in the form of tree trunks, we're putting on more tree trunks. The ocean is in the form of carbon, in the form of carbonic acid, we're making it all just building up. The rule of thumb is about half of it blows up in the air, a quarter in the ocean, and a quarter in those tree trunks. So if we weren't, the way you want to think about your question is, if we weren't those tree trunks, even more of it would be floating out there. We're lucky that the tree trunks are taking some of it, right? If we didn't have that water going into the tree trunks and that water going into the ocean water, then all of it would be floating out in the air. We would actually be taking my price back. So because the tree trunks and the ocean water, they got only taking half the rate than it would have. We're lucky in that way, but the fish are not lucky. Right, the little shrimp, or something like that, right? They're wasting away. Yeah.
But between disinformation in the marketplace and autocrats, take China, for example, who are hell bent on, taking over the world, and particularly economically.
Yeah.
And incentives to do that, doesn't appear to me that there's much to be optimistic about toward reversing that. I think everybody in this room, judging from the level of gray hair, and thinking, we're going to be running for. You don't want all this. Talk about some possible end dates, being,
Right.
we got serious issues.
Yeah. But how you let's do the important point, like, does China really care? I mean, I struggle with it. So it seems like they really do, on a high level, their leadership really does see this as a long-term threat to that, right? They want to, in the long term, switch to renewable, right? They want to, in the end, switch to moving forward, but they're still building a lot of natural gas, because they're still trying to develop, right? That's their number one goal. So you have these assurances, in the long term, we're going to transition over to these short term, we'll need to build more of this. So it just depends on, how quickly can they transition to, right? The US, we live here, but China was quite the greenhouse gas emitter. The US, China's number one emitter, we're number two. Everybody else is way down there, half China, not China, the two big ones. So, how real is China's concerned about this? I don't know if they're not concerned, it's gonna be harder, but they're also only 30% of the globe, even though they're the number one emitter, they're only 30% of the globe, the other 70% of the country is not China. So, it's a tough problem, it's a global problem, it's everybody, we have to be having to do it.
Disinformation is being spread about all of this. The good news is the scientific community appears to be aligned on the problem.
Right.
But all the disinformation is generated here and through a lot of the developed world.
Yeah, I mean,
To dissipate the will of the people to insist this goes down.
well, no, I mean, people, a lot of one would just say you can read anything on the internet, right? You can read anything you want on the internet, claim anything. I think people are starting to get wiser to that. So if you look at like public opinion surveys over time, fewer and fewer people think it's fake, right? If you look at like US public opinion data, way more people in the US thought it was fake like 25 years ago than today. So if things are moving in the direction of people trading this as serious issues, then the business is bringing a really serious issue, right? And I think that's maybe the most important, right? Because businesses that make most of these missions. So I'm a little bit less concerned about the public information aspect. I feel like more people know, and more people are making those decisions. But China is very concerned me because that's 30% of global emissions. That's a big chunk. And how serious are those leaders about it? They're all serious about it. They're looking at all the wind and solar building, and they're also building a lot of coal natural gas. So they're just building everything. They're trying to solve that. Yeah.
I thought it was interesting when you said an order of magnitude, how much where coal was, and then gasoline, and then natural
Oh, I
gas.
probably exaggerated. They're not quite. Coal makes about twice.
Order of
Yeah,
magnitude.
yeah.
What is it? Natural gas is 1, gasoline is 2.
Oh, yeah, great question. Natural gas is 2, oil is 3 equals 4.
Okay.
Yeah, natural gas 2, oil 3 equals 4. The unit, the conventional unit, natural gas 50 on the carbon intensity scale, oil 75, and coal 100. So, to make the same amount of energy from natural gas, we put half the CO2 in the air if we're making that same amount of energy.
Because the bit you hear right now, we have to go through a natural gas transition before we get to solar, because we got to get rid of coal.
Yeah, I don't know why it has to, but it's convenient, right? Natural gas is cheap. Right, natural gas is sort of the dominant source right now. So we're gonna coal, right? The more natural gas is in the market right now, the more it takes coal off, and that's great. And then the problem in the longer term, we're gonna have to get off natural gas and coal. So that's sort of a question of timing, I would say. Anyway, sorry, that's why I was asking for people, I don't want to waste time.
It's very.